Welcome back, and today we're going to solve Laplace transformation using the Convolution theorem. So I have here the Laplace of your integral sine t minus lambda times cos lambda d lambda. Okay, first let us use the trigo identities. So this is actually your 1/2. So I have here your integral of 0 to t. Now we have here sine of what is your t minus lambda plus lambda plus sine of your t minus lambda d lambda. Now this will be 0, this will be negative 2 lambda. So we have here 1/2 integral sine of t plus this will be your sine of t minus 2 lambda. Now we integrate. This will become 1/2. So since sine t, so your t is always your constant, because based on here we have your lambda as your variable. So this will become your lambda sine of t minus this will become 1/2 of your cos sine t minus 2 lambda with 0 to t. Now let's put the variables. We have here 1/2 t sine of t minus 1/2 cos t minus 2 t minus 0 sine t minus 1/2 cos t minus 2 times 0. So this will become this t, this will become negative t, but we have here the rule or the trigo function that cos negative t or negative x is just equal to cos x. So we can leave this t. This will be cancelled out. Okay, now what's left here? So it's 1/2 t sine of t. So this we added, so it's negative 1/4 cos t. Don't forget 1/2, so this will become 1/8. So this is not the final answer yet, so you have to last transform this equation. So you have 1/2 Laplace of t sine of t minus 1/8 of Laplace cos t. Okay, here we can use your table. So we can hear negative 1 d over ds times Laplace of sine t. You know that sine t is just 1 over s squared plus 1. So derivative of 1 over s squared plus 1, so I'll put here is just equal to your negative 2s all over s squared plus 1 raised to 2. Don't forget the negative here, but cancel out, so this will be positive, minus 1/8 cos of t is just equal to your s all over your s squared plus 1. So this is my final answer for my number 2. Okay, this is my number 4. So let's start off here the integral. So we can use here the by parts. So that my u is equal to my lambda, so du is equal to the lambda, and my sine lambda is my dv, and its integral is just negative cos lambda. So we have here negative lambda cos lambda minus integral to 0 to t. This will be negative cos lambda d lambda. This is equal to your negative lambda cos lambda plus sine lambda. Now we have here 0 to t, so let's implement this. So it's negative t cos t plus sine of t minus negative 0 cos 0 plus sine of 0. So this will be cancelled out. What's left is this. Now we're gonna have the Laplace of your negative t cos t and also the sine of t. Okay, here we can use here your table, which is negative 1 d over ds times Laplace of your cos t actually equal to your negative s squared plus 1 all over s squared plus 1 raised to 2 plus Laplace of sine is just 1 over s squared plus 1. We can further simplify. So you have s squared plus 1 raised to 2. It's least common. And we have here negative s plus 1 plus s squared plus 1. Cancel this out. So what's left here is equal to your 2 all over s squared plus 1 raised to 2. So this is my final answer for my number 4. Okay, this is my number 8. We can't solve number 6 because we cannot use the big f of s within the inverse Laplace, which is impossible to solve and which is never. So let's skip number 6 because number 6 we cannot Laplace transform it because there is a big f of s. So this is our number 8. So first we use the convolution method. So we have here inverse Laplace of 1 over s plus 1. Okay, then we let here f of s, we let this one a g of s, which then equal to your 1 e raised to negative t. This is not the final answer yet, so we have to integrate to 0 to t e raised to negative t, or this is your b t. Okay, so this is not the final answer yet. We have to integrate this to 0 to t e raised to negative of t minus your lambda d lambda. Okay, now we're going to separate this e raised to negative t times your e raised to e lambda d lambda. We can take out this, and this is negative, so we put down e raised to t. This is what's left inside is e lambda d lambda. So the integrate of this is just e lambda all over e t with respect to 0 to t. So let's bring the et up. So you have here equals to your e lambda minus t with respect to 0 to t. Now let's put out the variables. So you have e t minus 1 or t minus t minus e 0 minus t. So this will become 0. E raised to 0 is 1. This one will be e raised to negative t. So my answer here is 1 minus e raised to negative t. Okay, now this is our last number. So again, let's separate this. So we have a Laplace of your 1 over s plus 1 times 1 over s plus 1. So the same. So that list would be your f of s, g of s. Now we have e raised to negative t. Have the star here of e raised to negative t as well. Now let's integrate this to 0 to t, which e raised to negative lambda times your e raised to negative of t minus lambda d lambda. Again, let's separate this. We have e to negative lambda times e raised to negative t times e raised to lambda d lambda. So we took out here the e raised to negative t, but this is negative, so we can bring it down, or we can say it like this. So c negative t But inside, we notice that when we add this together, this is equal to 1. So what's left inside is just d lambda. So here, you know that the equation of d lambda is just e raised to the negative t of lambda with respect to 0 to t. So let's put it in here. You get e negative t multiplied by your t minus e raised to the negative t times 0. So this will be cancelled out. So the answer here is e raised to negative t of t. I learned about Laplace transformation by using the convolution method. This is one of the methods used in Laplace transformation and also in the inverse Laplace. But some of the problems we can easily use the partial fraction method or the tabular method by just looking at it. But this is also another way that we can solve it much easier. Thank you so much and see you in the next video.